So now that we've got the derived file set up and the part that we want to machine inserted into that file, we need to decide how we want to go about machining this part. So if we take a look at the part, we'll see that it's got lots of different features on all the different faces. And ideally we'd like to machine as many of those faces as we can in one go. Which means for this part we're probably best using this DM12 dovetail setup here. So I'll hide the fixture plate setup for now, and then I'll show you how we go about attaching this part to this dovetail base ready for machining. Before I do that though, I want to note a few things about this dovetail base. The first of which is that I've designed it according to the 5th Axis specification sheet, but there are a few things that I've either changed or just left out. The first of which is that I haven't put a radius. If I turn this around, rotate it, I haven't put a radius on the inside corner here, whereas you can have a radius up to 0.38. This really depends on the cutting tool that you're using or that your dovetail supplier uses. So I've just left that as is. It doesn't really matter. It just depends on what cutting tool you use. The second thing to note is that if you want to change this dovetail, the dovetail base, then you can do so using these two sketches here. However, if you look in the derived file, you'll see that these sketches just appear as unconstrained, and you can't actually edit them in this file because they're derived sketches. So you need to go into your master file and edit them in here. So I already have one sketch open because this is the next thing I want to show you. So yeah, if you come in here and want to change anything, it's the same. It looks the same. It's got the same layout, so it's just the same two sketches underneath the dovetail setup. And you can come in here and you'll see you've got all the constraints and dimensions. So the second thing that I've changed on top of that corner radius is this dimension here. So it's specified as 3.03, and what I've done is I've drawn in the 3.03 diameter cut out here, but I've actually made it ever so slightly bigger. So it goes to the same depth, both are on the same tangent there, but it just goes ever so slightly wider. And that's to allow a little bit of extra room for this pin, because when I machined it on my machine, I found that the slot was just a little tight. So I increased that, the diameter of this curve and the width here to 3.1 rather than 3.03. So if you want to change it, just come into this sketch in the master file, and you'll find the extrusion in the history here for this slot, and just change the extrusion to extrude this area and not this outer area. So that's the way to change that. If you're ordering dovetail stock like you can in most countries, then you don't even need to think about this, because they'll machine this slot very accurately, so you'll get a nice fit on the pin. I just found that when I was machining it myself on the Pocket NC, which I'll show you how to do in a later video, I just wanted that little bit of extra clearance. When using this line, or these inner lines for my cutout, the 3.03 distance, it did still fit, it just rubbed a little bit, which I didn't like, so that's why I switched to this outer line. But yeah, for most people, if you're ordering your dovetail stock, which is much easier anyway, you don't even have to think about changing this. The final thing to note is in sketch 1, so I'll finish this sketch, and I'll just open sketch 1. Zoom out, hide this fixture plate. Right, so with sketch 1, I've drawn this sketch exactly as 5th Axis tell me to, and everything is measured as a distance from the center line. So all the measurements are given as a distance from the center line of the DM12 block, and then the center line of this DM12 block I've designed so it's on the center of the B-axis here. So there's the center point, and that sits exactly above the center of rotation of this B-axis, the B-table, sorry, here. However, when you model it like that and model it correctly, what you do get is this very, very small gap here, which doesn't reflect how it would appear in real life, because in real life you push this corner, this dovetail, up to be flat against this. So it's slightly strange that it appears like that, but if you see that, don't worry, that is the dovetail is actually modeled correctly according to the DM12 design specifications. And just know that this gap is very, very, very small, so it's not going to have any effect anyway.